Valves are used throughout industry, sometimes to control the flow of solids like sugar or flour, but most often to control the flow of fluids and gases like water and steam. Valves may be used to isolate parts of a system, stopping the flow entirely. Or they may be used to regulate the flow, increasing or decreasing it on demand. Often, valves are used to change the direction of flow, or to prevent flow in one direction. Finally, many valves are installed just for safety reasons. Even though they may never be used, they are critical to safe operation. In this program, we're going to look at several of the most common kinds of valves, and we'll take them apart so you can see how they are constructed and how they work. Then we'll show you some of the common repairs that are made to valves. And finally, we'll reassemble a couple of valves and reinstall one in a line. Now, the first thing to think about when you're working on any valve is safety. The facility in which you work will have specific lockout procedures which must be followed whenever they are performing maintenance on valves. These procedures may not be the same for all valves, so make sure you understand the procedures for the valve or valves you are working on. The procedures may be as simple as a single lockout or tagout, but they may also include much more complicated procedures, such as multiple lockouts and tagouts, or the wearing of personal protective equipment like bodysuits and respirators. No matter what procedure you follow, when you first break open a line, always stand to one side, away from the direction that gas or liquid will first escape. Let's start by looking at a typical valve. This common gate valve has the same basic parts as all valves. Now, of course, if the valve were connected into a system, we'd have to lock out properly first. But it's not, so let's take it out of the line by unbolting its end connections. In this case, the end connections are flanges. But you'll also find screw connections like this, as well as permanent connections like soldered or welded connections. These usually require the valve to be cut out of the line if it is to be removed. With the valve out of the line, we can take it apart. Here's the body, the main part of the valve. And here's the bonnet, the top of the valve. The bonnet usually guides the stem, which turns one way to open the valve, the other way to close it. When the valve is closed, the disc fits firmly against the valve seat. Notice that the stem passes through the bonnet. When a valve leaks, this is often where it happens. Fluid under pressure in the piping seeps through the clearances between the stem and the bonnet. The seal at the stem may be as simple as O-rings or a gasket. But often, and especially in larger valves, the seal is packing. The packing is stuffed around the stem into the stuffing box in the bonnet. On top of the stem is the actuator, usually a hand wheel or lever if the valve is opened or closed manually. Large valves may include a gearbox to make it easier to open or close the valve. Many valves, however, are actuated automatically and may be powered by various pneumatic or hydraulic means, sometimes by an electrically operated solenoid, or, on larger valves, by a motor. The major difference between valves is the type of disc used to open them up and close them back down. Let's run down the major types real quickly, then take a look at some common maintenance problems. This is a typical gate valve. Its disc, which slides up and down in the valve seat, may be tapered or straight. Both the disc and the seat are ground to a smooth finish to ensure good metal-to-metal contact so the valve can close completely. In some applications, when used at high pressures, for example, the disc and the seat may be hardened. When disassembling a gate valve or any valve, take extra care not to scratch or nick the edges of the disc or the valve seat. Any damage may prevent the valve from sealing correctly. Gate valves are used to isolate parts of a system. Normally, they are fully closed or fully open. Gate valves create very little pressure drop from one side of the valve to the other because there's very little turbulence when the valve is open. These valves are often used in lines where flow must be reversed because flow rates are the same in both directions. The globe valve is different. When totally closed, it can be used for isolation, just like a gate valve. However, the globe valve can also be used for throttling or changing flow. A globe valve provides good control of flow from the moment the disc and valve seat are cracked open. Once again, remember to be especially careful of the disc and the valve seat because any damage will change the flow characteristics of the valve. Different globe valves will often have different kinds of discs to meet different flow control requirements. For example, the common needle valve is a type of globe valve with a disc that provides precision flow control at continuously varying flow rates. Often, globe valve discs and seats are replaceable, and they may be made from a variety of non-metallic materials. Many globe valves are an in-line style, like this, but they are also available with a right-angle flow pattern, like a faucet, and with a Y-shaped flow pattern, like this. Next, let's look at three other kinds of valves: the plug valve, the ball valve, and the butterfly valve. Each of them is a quarter-turn valve. This means it takes only a 90-degree turn, like this, to take the valve from fully opened to fully closed, or closed to open. All three of these quarter-turn valves can be used for isolation or for throttling control. And all three create very little pressure drop because the fluid can flow directly through them. Let's look at each of them. The plug valve is available in many different designs, but they are all basically a round plug, either straight or tapered, with an oval or rectangular hole through it. The plug is inserted into the valve seat. Straight plugs usually have valve seats made from rubber, Teflon, or some other resilient material that will spring back to its original shape after being compressed. Tapered plugs usually operate with metal-to-metal contact between the plug and seat. Frequently, a lubricant is used in a tapered plug valve. The lubricant is injected into the valve at a pressure higher than the fluid being pumped, so it seals the valve as well as makes it operate more smoothly. The ball valve is similar to the plug valve, except that a ball with a hole bored through it is used instead of a plug. The valve seat is resilient, usually made of Teflon or rubber. The disc on the butterfly valve allows free flow around itself when the valve is open. Closing the valve forces the disc into a valve seat, which is usually a resilient ring. Often the actuator of a butterfly valve requires some kind of lever or gearbox because a relatively large force is required to open and close the valve. Now, except for the lubricated plug valve, all the valves we've shown so far have stems that are exposed to the material flowing through the valve. This means that some type of seal, like packing, must be provided to prevent leakage around the stem where it passes through the bonnet. When leakage past the stem cannot be tolerated, a diaphragm valve may be used. This valve has a sheet of flexible material, usually some type of rubber or Teflon, often reinforced with fiber. The diaphragm serves as the disc while the body serves as the valve seat. The sheet is bolted in place between the bonnet and the body, so the valve stem is never exposed to the material that passes through the valve. These valves are often used to handle hazardous materials like caustics and acids, so the bodies may be made of plastics or special metals like lead. Diaphragm valves may be used for isolating or throttling control. When they are used for throttling control, they usually include a dam or weir, which serves as the valve seat. Valves with weirs may make lines difficult to drain, so make sure you follow all the recommended safety procedures when working on diaphragm valves. Some diaphragm valves include a V-plug in the bonnet to provide an early warning of internal wear. The plug has a groove on one side which produces a small leak if the diaphragm has deteriorated. Another common valve is the check valve, which checks or stops free flow in one direction, while allowing free flow in the other direction. The most common kind is the swing check valve. It has a hinged flapper that moves up and out of the way when fluid flows in one direction, then closes if the flow reverses. Finally, the relief valve. A relief valve is like a right-angle globe valve with a spring on top of the disc that holds it on the valve seat. When the internal pressure in the valve exceeds the pressure supplied by the spring, the valve opens. Many relief valves open gradually, releasing small quantities of gas or fluid. Other relief valves relieve the pressure quickly by ejecting large quantities of gas or fluid. They are called safety valves. The installation and maintenance of both types of valves requires special training. In many facilities, the work may be done only by a certified individual. Do not perform any installation, maintenance, or adjustment of a relief valve or a safety valve unless you are qualified to do so. When you are performing maintenance on valves, the most common maintenance problem you'll encounter is leaking. Usually, leaks occur in one of three places: at the end connections, between the body and the bonnet, or at the stem. Very often, a leak can be stopped just by tightening down a nut or bolt. However, if the leak is not fixed, you may have to replace gaskets, O-rings, or packing. Both gaskets and O-rings are normally used between bolted flanges at the end connections and between the body and the bonnet of the valve. O-rings are usually made from rubber or rubber-like compounds such as Buna-N. Gaskets are often made from rubber, but they may also be made from metal, cork, Teflon, and other substances. In the past, many gaskets were made from asbestos, a carcinogen, so make sure you know and follow the proper procedures when working with this substance. When installing a replacement gasket or O-ring, always refer to the manufacturer's instructions. When replacing the seal between flanges, make sure the flanges are not warped, bent, or otherwise damaged. Inspect the gasket or O-ring carefully and inspect its seat or groove for nicks, burrs, or debris. In general, use as thin a gasket as possible. The thinner the gasket, the more likely it is the hold-down bolts can be correctly torqued, and the more likely it is the bolts will stay correctly torqued for a long period of time. Make sure the O-ring is the correct size, and avoid stretching or twisting it during installation. When tightening bolts on flanges or on a bonnet, do it gradually. The usual procedure is to apply 25% of full torque and use a crisscross pattern as the bolts are tightened. Then apply 75% torque as you repeat the same crisscross pattern. Then, on the last two passes, apply 100% torque and repeat the same pattern. The full torque required will vary depending on the valve, the gasket, as well as the bolts. Be sure you follow the manufacturer's instructions. If the leak is around the valve stem, and if tightening down the gland follower or packing nut does not stop the leak, you will usually have to replace the packing. Most valves are packed with standard packing in which several rings of packing material are compressed into the stuffing box from above. The first step when replacing packing is to make sure the valve and the line are properly locked out. Never try to replace packing on a valve that is under pressure. Make sure you know and follow the correct lockout procedures for the valve you're working on. After lockout, you should clean off the valve, then remove everything from the stuffing box. To prevent damage to the stuffing box and stem, be sure the tools you use are made of soft metal. If you find packing that is rock-hardened, it may be asbestos. Make sure you know the proper procedures for its removal and disposal, because it may be dangerous to your health. Clean and inspect the stuffing box before adding more packing. If you are using a bushing to reduce the number of packing rings required, the bushing should go in first. When adding the new packing, cut it carefully to size, or use pre-formed packing. Add the packing one ring at a time, twisting it gently open and staggering the joints. Compress each ring after it is inserted. After the gland follower is in place, be sure to cycle the valve several times to be certain it operates properly. This is especially important with valves that are actuated automatically. The actuator must be able to move the valve. Valves may also leak internally between the disc and the valve seat. When this happens, the disc or the entire valve may be replaced because the cost of repairing some valves is greater than the cost of replacing them. But sometimes all that's required is a thorough cleaning to remove buildup from the disc or the valve seat. To determine if the fit between the disc and the valve seat is correct, the valve may be blue-checked or blued. This process involves putting a very thin coat of blue dye, Prussian blue, onto the valve disc or the valve seat, then pressing them together. When the valve seats, the blue dye will be transferred from one surface to the other. The position of the band of die, its width, or the presence of any breaks or gaps will indicate if any repairs are required. Sometimes, for very small imperfections, the disc may be lapped. In this process, progressively finer grades of abrasive lapping compound are used to polish the surfaces. Valve seats may also be ground in. Sometimes a valve grinder is used to achieve the correct seating. When imperfections are more pronounced, the valve components may need to be machined in order to restore the tolerances required for normal operation. When installing or reinstalling valves, remember that a valve will be easier to work on if it can be installed with a stem pointing up. Use the proper fasteners, both on the valve itself and on the connections to the line. For example, if the installation requires an SAE2 bolt, make sure you use an SAE2, not just another bolt that fits. Make sure the valve is properly supported. Valves that cause the line to sag may be distorted and fail to operate correctly. In this program, we have seen some of the common valves used in industry. We have seen how they are constructed, how they work, and we've seen the kinds of maintenance they may require. Whatever kinds of valves you work with, remember that following good maintenance and repair practices will help you get long, reliable service.